Good, I'm still recording. All right, let's look at our next example. This time we have a cotangent. Oh yeah, things are starting to get a little more interesting here, huh? Let's see. We solve this stuff. And it says solve cotangent of x minus pi over 2 plus the square root of 3 is equal to 0 on the interval from 0 to 2 pi. So this time they don't want me to solve it on all real numbers, just this interval. So what I do is I take this and I solve for cotangent. So I'm going to subtract square root of 3. So I have cotangent of the argument, x minus pi over 2 is equal to negative square root of 3. Now, what you do is you just treat the argument as one part right now, okay? You say, where do I have a cotangent that is negative square root of 3? Think about your unit circle first. Where do you have a cotangent that is negative? Well, that'll be in this quadrant and then that quadrant right there, right? Okay, so where do you have a cotangent that is negative? Those two quadrants. Now, where do you have a cotangent that is square root of 3? Well, let's figure that out. Let's do some scratch work over here. I know that at pi over 6, let's just focus on the first quadrant right now, okay? At pi over 6, what is my ordered pair I have on the unit circle? Wouldn't it be the square root of 3 over 2 comma 1/2? All right. Now, what if I calculate the cotangent at pi over 6? What is that going to be? That's going to be cosine over sine, square root of 3 over 2 over 1/2, right? And what does that give me? Square root of 3 over 2 times the reciprocal 1/2 times 2 over 1, and I get the square root of 3. So what are we saying here? We're saying the cotangent of pi over 6 is square root of 3. So where is my cotangent going to be square root of 3? Or in this case, a negative square root of 3? At a reference angle pi over 6. So the reference angle pi over 6 here, and a reference angle pi over 6 here. But what actual angle is this right here? It is what? Pi, back off pi over 6, right? Or pi minus pi over 6, which gives me what? 5 pi over 6? So I take the argument, which is x minus pi over 2, set it equal to 5 pi over 6. Now, could I do this? Can I say, okay, 2 pi back off pi over 6 gives me this other angle right here. So 2 pi minus pi over 6. So I'm going to have my argument, x minus pi over 2 is equal to, what's 2 pi minus pi over 6? 2 pi minus pi over 6. Well, wouldn't that be 12 pi over 6 minus pi over 6, or what? 11 pi over 6. All right. So there we go. I got it set up pretty much right. But let me rewrite this as x minus pi over 2 is equal to 5 pi over 6 plus 2 pi in here. So in other words, I'm adding 2 pi in. That's what I would normally do, right? But since I'm dealing with the cotangent, it only has a period of pi. So instead of 2 pi in, I'm going to add just pi in. How about this one? X minus pi over 2 is equal to 11 pi over 6 plus, normally I would add 2 pi in, right? But since we're dealing with cotangent, we're going to add pi in. All right, let's solve here. So we're going to do what? Add pi over 2 to both sides. So we're going to have 5 pi over 6 plus pi over 2 plus pi n. And let's see, what is this? That's really 3 pi over 6 plus 5 pi over 6 gives me 8 pi over 6 plus this pi n. Well, I could simplify that. I could say, what's 8 over 6? Well, you can divide them both by 2, right? So that gives you what? 4 pi over 3 plus pi n. Let's do the same thing here. Let's add pi over 2 to both sides. So x is equal to 11 pi over 6 plus pi over 2 plus pi over n. So x will be, isn't this really 3 pi over 6? 3 pi over 6 plus 11 pi over 6 gives me what? 14 pi over 6 plus pi n. What's 14 over 6? What can I divide those both by? A 2, and I get 7 pi over what? 3 plus pi n. Alright, so what am I doing? I'm solving over this interval, right? 0 to 2 pi. So what do I need to consider? I need to consider those n values. Let's see what I get whenever I consider different values for n. How about when n is equal to 0? When n is equal to 0 here, what do I get? 4 pi over 3. How about over here when n is equal to 0? What do I get? 7 pi over 3. How about when n is equal to 1? What am I going to get? I'll get 4 pi over 3 plus 1. So what is that? Plus 1 pi. That's what? 4 pi over 3 plus 3 pi over 3? So that gives me what? 7 pi over 3 again? How about when n is 1 here? What do I get? 7 pi over 3 plus 3 pi over 3, right? What does that give me? 10 pi over 3? 10 pi over 3? What's 10 pi over 3? Same thing as what? 3 and what? 1/3 pi? 7 pi over 3 okay? Yeah. 10 pi over 3 okay? No, can't have that one. That one's too large, right? Let's just make sure. What about when n is equal to 2? Think about this for a second. If I have 2 pi, n is 2, I have 2 pi, and I'm adding something else to it, some positive value, I'm going to be outside of that automatically because we'll go up to 2 pi. Let's do something else. We never really considered a -1 or a -2. What about when n is -1? What do I get? I'm going to have 4 pi over 3 minus pi, right? Or I could say 4 pi over 3 minus 3 pi over 3. Well, what does that give me? 1 pi over 3? Or pi over 3, right? That's okay to have in this interval right here. How about over here? Well, when n is -1, what do I get? 7 pi over 3 minus pi? Or 7 pi over 3 minus 3 pi over 3, or what? 4 pi over 3? 4 pi over 3? That's in that interval. How about when n is equal to -2? When n is -2, wouldn't that be -2 pi there? Well, what's 1 1/3 minus 2 pi? That gives me a negative number here, which I can't have a negative number between 0 and 2 pi. How about over here? What if n is -2? Then I have 7 pi over 3 minus 2 pi, or I can say 7 pi over 3 minus what? 6 pi over 3? But what does that give me? That gives me pi over 3, right? I can have pi over 3. Use n is equal to negative 3. You're going to get too large of values again, or too small, I guess you could say. Okay? So what is their solution set from 0 to 2 pi? It is pi over 3, 4 pi over 3, and 7 pi over 3. Now, why did I get all these duplicates? Because really, to be honest with you, whenever we looked at that unit circle right here, and we came up with this reference angle pi over 6, we didn't need this one, pi over 6 right there, because of the period of the tangent being pi. So we really could have just dealt with this stuff right here for cotangent.